Hello knowledge seekers. Today our subjects will be control valves. I want to discuss about different types of control valves. All of them might not be used in the pipeline, but it is being used in the plants and refineries. So let us have some overview of control valve. What is control valve? Control valves are such type of valves which are controlled remotely to maintain flow rate, level, pressure and temperature. Position of control valve in a control loop. The diagram is self-explanatory to show you where the control valves are being used. You see the arrow direction is the flow of the fluid or gas. Then we put the control valve there, and through IP converter we have a controller. Those are all instrument part, and we have a transmitter also. From orifice we can control the flow. So this is a schematic diagram for control valve, only for your information. All these diagrams here are very simple to have a very good understanding of control valve. You see, this diagram is for control valve which are controlling the flow. Instrument air is being used to control this valve. This one is a control valve which is used to control the level of some liquid. This diagram is for control valve where it controls the pressure. Each and every control valve consists of some displays, some controller, and instrument air is also being used to help the control valve for the purpose intended. Control valve, you can see it is controlling the temperature of superheated steam, where the input is the superheated steam and outcome is the hot water. Let us have some look about the parts of a typical control valve. The diagram and the parts list I have provided. You can stop the slide and you can have a look if you like, but I can read it for you. Actuator, diaphragm, stem guide, spiral guide plate, ball bearing, multiple springs, spring adjustment screw, yoke, travel indicator, glands packing, plug, seat rings and bonnet. Trim includes all the parts that are in flowing contact with the process fluid except the body, bonnet and body flanges and gaskets. The plug, seat, stems, bushings and cage are some parts of the trim. Classification of control valve on the basis of actuator action. It can be direct acting at the left and it can be reverse acting. Classification of control valve on the basis of valve action. Also it can be direct acting and reverse acting. In case of reverse control valve, the stem extends on the loss of air pressure, and for the direct, the stem retracts on the loss of air pressure. This is the difference. Failure mode, for the direct, valve body action is also direct. Control valve action, air to close, and failure mode is fail open. Valve color is green. Actuator action, when it is direct, in case of reverse, air to open, fail is close and the valve color is red. For actuator action reverse, the valve body action is direct, air to open, fail close and the valve color is red. For the actuator action reverse, valve body action is reverse, control valve action will be air to close, fail open and the valve color is green. Control valve flow characteristics. This is an important term. Trim design will affect how the valve capacity changes as the valve moves through its complete travel. Because of the variation in the trim design, many valves are not linear in nature. The relationship between valve capacity and the valve travel is known as the flow characteristics of the valve. Valve trims are specially designed, characterized in order to meet the large variety of control application needs. These curves are based on constant pressure drop across the valve and are called inherent flow characteristics. When valves are installed with a pump, pipe, fittings, and other process equipment, the pressure drop across the valve will vary as the plug moves through its travel. Types of control valve. There are two basic types of control valve, rotary and linear. Linear motion control valves commonly have globe, gate, diaphragm, or pinch type closures. Rotary motion valves have ball, butterfly, or plug closures. Each type of valve has its special generic features, which may, in a given application, be either an advantage or a disadvantage. Control valve specification. In addition to the linear and rotary, control valves also classified according to their guiding system and the types of service they are used in. Single-seated globe valve, the advantages is high rangeability, tight shutoff, frequently used in sizes less than 2 inch. And the disadvantages of globe valve are unbalanced design usually requires large actuator, low pressure recovery characteristic. Double-seated globe valve advantages are high flow capacity compared to single-seated globe valve of same size, high rangeability, balanced design requires smaller actuator. It is being used for over 2-inch dia piping. Disadvantages: relatively high leakage rate, low pressure recovery characteristics, erosion may occur due to leakage characteristics. Three-way globe valve. Advantages: good for blending and diverting application, can replace two-way valve in certain application. Frequently used for temperature control systems at heat exchangers. Disadvantages: cannot control total flow, may require different size ports. Angle valve body. Advantages: good control characteristics, high rangeability, tight shutoff, minimizes erosion problem, good for flashing services. Disadvantages: normally made in sizes 2 inch and above. Saunders diaphragm valve. Advantages: high capacity, low cost, good for slurries, provide tight shutoff if pressure is low. Disadvantages: poor control characteristics, low rangeability, short diaphragm life, slow response speed. Butterfly valve. Advantages: high capacity, economical especially in larger sizes, low pressure drop, does not permit sediment build-up, good for slurry services. Disadvantages: operating torque is high, requires larger actuator. Tight shutoff depends on the use of resilient sheet, which is temperature dependent. Ball valve. Advantages: high capacity, good control characteristics, good rangeability, good for slurry services. Disadvantages: limited operating pressure, not good for high pressure drop. Pinch valve. Advantages: high capacity, economical, good for slurries. Flowing medium does not contact working parts. Disadvantages: poor control characteristics, not good for high pressure drop application. Plug, which is very important for a control valve. Contoured plug is top guided, shape of the plug is flat, which are quick opening, a bit conical, linear, tapered but not conical, equal percentage. Characteristics of valve plug. You can see quick opening, linear and equal percentage. The diagram explains, and here is the actual photo: quick opening, linear and equal percentage. Picture of some typical control valves. This is a globe valve, angle valve and two-port valve, cage valve and an aerodynamic noise reduction, butterfly valve, ball valve, control valve used as a shutdown valve. Seat ligature classification. There is no such things as bubble tight. Control valves are designed to throttle. However, this is not a perfect world. And control valves are also usually expected to provide some type of shut-off capability. A control valve's ability to shut off has to do with many factors. The type of valves, for instance, a double-seated control valve will usually have very poor shut-off capability. The guiding, seat material, actuator thrust, pressure drop, and the type of fluid can play a part in how well a particular control valve shuts off. There are actually 6 different seat leakage classifications. Most commons are Class 4 and Class 6. Class 4 is also known as metal to metal, whereas Class 6 is known as soft seat classification. Soft seat valves are those where either the plug or seat or both made from same kind of composition material such as Teflon. Let us see what are the leakage of control valves for different classes. Class 1 identical to Class 2, 3 and 4 in construction and design intent, but no actual shop test is made. Class 2 intended for double port balanced hinge port valve with a metal piston ring seal and metal to metal seats. Air or water at 45 to 60 psig is the test fluid. Allowable leakage is 0.5% of the rated full open capacity. Class 3 intended for the same types of valve as in Class 2, allowable leakage rate is limited to 0.1%. Class 4 is intended for single port and balanced single port valves with extra tight piston seals and metal to metal seats. Leakage rate is limited to 0.01% of rated valve capacity. Class 5 intended for the same types of the valve as Class 4. The test fluid is water at 100 psig or operating pressure. Leakage allowed is limited to 5 into 10 milli per minute per inch of orifice diameter per psi differential. Class 6 is the last one, intended for resilient seating valve. The test fluid is air or nitrogen. Pressure is the lesser of 50 psig or operating pressure. The leakage limit depends on valve size and ranges from 0.15 to 6.75 milliliter per minute for valve sizes 1 inch through 8 inches. So guys, this is end of the control valve overview. I will be very happy if you get some profit from my videos. If you like to have more topics related to pipeline construction and some quality or inspection related videos, please subscribe my channel so that you will get the first notification as soon as I put some video. Thank you. Signing off, Showman.